Hello everyone, warm welcome to TGIF, your weekly source to get the latest and greatest in tech. A lot is happening in the world of generative AI. Applications are being built with RAG being the foundation to augment the context of these models. But what if I have a niche problem that I want to solve, which is very industry specific and also something that is very relevant to my use case? Let's explore how we can solve this with the help of fine tuning. To join me on this short conversation, I have Priya Kedia, AI specialist, who is driving a lot of these conversations with customers on the ground. Warm welcome to TGIF, Priya.
Thank you, Divya. Thank you for having me here.
Sure. So, we've all heard about fine tuning, but customers are very confused in terms of when to use fine tuning and how to go about it, right? So, can you tell us why fine tuning and when to use it?
Absolutely, great question, right? So the common questions I get from customer, when should I fine tune? First, prompt optimization. Let's say your prompt is very large. You have a lot of SOP guidelines, few short examples and all that stuff, right? So with fine tuning, you can definitely make it concise. Second is cost optimization. Instead of using a very big model, let's say Llama 3, 405 billion, can we do away with a smaller model, right? That's where fine tuning gives you a great uplift. Third is basically domain adaptation. You have very niche industry, right? Let's say legal, let's say pharma, and these models have been trained on a wide range of data. So it might not perform well on those niche complex tasks, right? That's where fine tuning gives you a great uplift. Fourth is definitely your IP, right? Because when these models are exclusively trained on your data set, it gives you a kind of IP over those models. So that's a complete advantage that you get.
Wonderful. Thank you so much for the Priya. So, cost benefits as well as domain driven benefits
Absolutely.
is what one gets with fine tuning. Now, how to go about with fine tuning?
With 3 or 4 things that you need to be mindful of. First is getting a rich quality data, right? Because if you don't have a good data, your models will not perform great, right? So getting a data which is representative of a real world scenario. Second is getting the right compute, because these models are complex and you need a big model to support the memory footprint of requirement of these models, right? That's absolutely important. Now, third is equally important, getting the right set of hyperparameters, because LoRa, which is low rank adaptation matrix, commonly being used for all fine tuning perspectives, there are a lot of hyperparameters. What should be my alpha, what should be my rank, learning rate, and all that stuff. That's very, very important. So yeah, I think these are the top 3 things that you have to be mindful of whenever you are kickstarting any fine tuning activity.
Sure. Thank you. Thank you so much. And one last question, why fine tuning on Azure?
Well, that's my favorite question, right? So whenever you're running fine tuning on Azure, it gives you the benefits of cloud, right? You can run it on scale. You don't need to manage your, okay, you can run, I get to the serverless. That's the most interesting point. Let me keep that aside, right? You get the benefits of cloud, monitoring, security, scale in, scale out, all these benefits. Secondly, you don't have to manage dependencies, because whenever you have to fine tune the model, you have to run distributed training at scale. You need deep speed optimization. You need torch. So all those dependencies comes pre-packaged.
Sure.
Third is serverless. So instead of having your own compute, your big NC series, ND series, A100, V100, right? Azure gives you the benefit of running everything serverless, where you don't need to manage compute. Everything is paid on a token basis. So that minimizes both your fine tuning cost, which is your CapEx, and your inference cost, which is your OpEx. So those are primary benefits of running things on Azure.
Oh, tons of benefits in running your fine tuned models on Azure. Can we have a quick demo?
Absolutely. Let's get into it.
So I'm in the Azure Machine Learning portal. On the left-hand plate, you see model catalog, and this is where we have all the open source models available for inference and fine-tuning. Let's see what fine-tuning options we have. So here we have text classification, question answering, chat completion, image segmentation, and bunch of others. For the purpose of demo, let's pick chat completion. So here you can see we have bunch of meta models, Llama, and 5 models. Let's pick 5, which is the latest release from Microsoft. If you click on fine tune, you get 2 options. Pay as you go, which is basically fine tuning on a serverless API where you get charged only for the token that's being used in training data. Let's pick fine tune on a dedicated compute. Instead of going by the basic options, let's look at advanced options. So first you need to define a job name, experiment, and then you can define what task you're going to do. Here it's chat completion. Now we need to pick up a training data. I have already registered a data set over here. Let's pick and see what's there in this data. So here you see this is basically a classification task where given a premise and the hypothesis, the model needs to determine whether it's an entailment or contradiction or neutral. So we have the system message and a user message. Let's add this data set and hit next. Here you get all the hyperparameter options. Batch size, whether you want to apply LoRa based fine tuning, you get deep speed optimization. You can specify optimizers, what precision you want to fine tune on, and bunch of different parameters. Let's get started with the default options. Then we pick up a compute. Here I'm going to use A100 for fine tuning. Let's hit next, and then we can go ahead and submit a fine tuning job. Once you submit a fine tuning job, you come to the jobs tab. And this is where you get all the jobs that have been fine tuned. So if you click on jobs, you get all the experiments, jobs, what have been the loss functions, accuracy, and bunch of different metrics. Let's pick one job, which is text classification. So over here, once you hit to the metrics tab, you get to know what has been the accuracy, what has been precision, recall, AUC score, confusion metrics, bunch of others. Let's head on to the outputs, and there you get an option to register your model. So you need to make sure whenever your model is fine-tuned, you need to register it so that you can start running inference. Once you hit register, you need to decide a model type, and then you need to give it a name. Let's put text classification model, and then you can go ahead next and register your model. Once you have registered your model, you need to come to the models tab, and here you will get all the models that you have registered. Now let's pick text classification model, and here you see the deployment option. You can deploy it as a real-time batch endpoint if you want to do offline inferencing and as a web service. So the beauty of this is once you have fine-tuned your model, you can register it and deploy it as a web service and start running inference because you get a dedicated endpoint and key based on which you can just submit your request and start querying your model. So yeah, that's how you do an end-to-end fine-tuning on Azure.
A very comprehensive end-to-end machine learning platform for LLM apps and fine tuning.
Absolutely, absolutely.
Wonderful. Thank you, Priya. Thank you so much. This was very relevant, and thank you so much for the great demo.
Thank you so much, Divya.
Nice to have you on TGIF.
Same here. Thank you.
So, as you can see, we demonstrated a quick end-to-end pipeline with LLMs being fine-tuned and deployed on the Azure infrastructure. Stay tuned for more updates on TGIF. Thank you for watching TGIF. Stay safe, stay secure.